moment. All right, let's look at our first one here. There are more than one way to do this problem. Or there is more than one way, rather. There are multiple ways to do this problem, the first one. Can somebody give me one recommendation they would do to start this problem? Andy?
Don't you gotta find something that breaks negative 27 and the 3?
Good. So Andy's saying, what number 3 times gives me negative 27 when multiplied? What number is that, Andy?
Negative 3.
It is negative 3. Well done. Again, the squared remains outside, but the cube root of negative 27 is just negative 3. Again, because, try it in your calculator if you have to. Negative 3 times negative 3 times negative 3 gives me negative 27. Now what's negative 3 squared? 9, right? So what's the answer?
9.
Okay, that's one way to do it. That's how I would do it. What's another way to do it? There's definitely another way to do this. So this is one root. I'll leave that in green. The alternate root I'll write in red. What's the alternate way to do this? Yes, very good. Thank you. So you start by doing this. You write it in rational exponent form. Remember, this is radical form it started with. This is converting to rational exponent form. Now, I can't do this in my head like this, so you can just type it in your calculator now. So if you type this in your calculator, somebody tell me the keystrokes I would type exactly, verbatim. What would the keystrokes be? If I were to type this in my calculator, what buttons would I press in what order?
Oh,
Mariana?
parentheses, negative 27, close parentheses, period, and then 2 divided by
Shut up.
If I do what you just said, listen carefully, please. If I put it like this, it's going to do negative 27 squared and then divide by 3. But what do we want to put around it? Very good. Because our exponent is a quantity, right? And if you tried that without the parentheses, that's what one of those other choices are, by the way. The other choices that are here are if you mix up the 3 and the 2, then you did 3 halves instead. That's another one of the choices there. Okay, so all those choices are there as common mistakes. You know, another choice will be tomorrow. I know there's not 6 choices, but negative 9 would definitely be a choice on kind of like this. Because a lot of people do negative 3 squared. And if they type it in, by the way, please do not type this in your calculator. Negative 3 times negative 3 is just positive 9. A lot of people type this in the calculator, and when you type it in the calculator, you have to do it like this. But a lot of people forget the parentheses around the negative 3. And if you type in the calculator just negative 3 squared, you're going to get negative 9. So negative 9 will be another choice, just to give you a heads up. I don't make negative 9 a choice sometimes only because then people see 9 and negative 9, they're like, it's got to be one of them, right? It's on there twice, it's probably one of them. Okay, be careful. It's not always work that way. It doesn't always work that way. Think about that before you choose. So again, one root is this way, one root is this way. And if you do this, you'll also get 9 as your answer. Number 2.
Yeah.
Number 2. What are my steps here? What are my steps?
distribute.
Okay, distribute what?
The negative 2
And the?
3.
What are those called?
Exponent.
Thank you. So distribute the exponents is my first step. So distributing my exponents. The negative 2 times the negative 2 gives me positive 4. That's the first one. Then the negative 2 times the 3 gives me negative 6. That's the first parenthesis set. Hurry up. The next parenthesis set.
The 3.
Very good, Mariana. 2 to the third, please. A lot of people have been putting 6 down there. You're not doing 2 times 3 there. Again, you're raising the number 2 to the third power. So we're going to have to do 2 times 2 times 2 there. A lot of people keep putting down 6. Be very careful, please. Then we get?
X to the third, Y to the 9, and D to the third.
Well done. Now, what do I think next? What's my next step?
Combine like, wait, no.
Bring the what? Very good, Barbosa. Awesome job.
Very awesome.
Bring that negative down to the bottom. So I would simply just do this on my work. I would go like this. That's what I would do. Because I don't want to write the whole line, right? Remember, it's all about saving time, SAT. Okay, perfect example problem right from the SAT right here. Okay, don't waste your time. Just put the y6 down below and get rid of it up top. Now, let's go ahead and start analyzing. Up top, I have x in 2 locations. Everybody see that? Okay, so what do I do to them? Good. So I take this, I'm going to get x to the 7th up top now. Hang on. So my x's are done. Put a line through them, please, so we know we're done. What about the z's?
Yeah, Z3.
There's only z3, right? Everybody see that? All there is z cubed, so put z cubed down now. Next, what's 2 to the 3rd?
8.
8. So where does that go? Top or bottom?
Top.
Good. There's no negative, so I don't have to move it. And then finally, so we're done with that. Finally, I've got 9 y's up top and 6 down below.
Subtract.
Good. So where are they up top? How many? So is there anything in the bottom?
No.
Choice E.
Are we trying to do this?
Okay? No, this is the same practice as always, guys. Same practice as always. So again, take a look at your problem here. 8, x to the 7th, z to the 3rd, y to the 3rd, all over. What's it really all over? 1, but it doesn't show it. We don't need it. Okay, because there's nothing left there. Can somebody explain to me again, please, where this came from? Y to the 3rd. Where did the y to the 3rd come from again?
You track, because it was a negative, just cross it out,
I don't know what you mean.
Okay.
And then whatever's left on whatever's left, you need to.
What's another way of thinking about it, though, besides subtracting? What is y to the 9th really? How many y's?
9 on top, 6 on bottom.
You don't have to do this, but I'm trying to help you guys think about it this way. You can do that, and you can write this as this. And then these 6 on the bottom here
You can
cancel with 6 up here.
6 up there and you get.
Thus, I'm left with 3. Again, think of this as 6 y's. Think of this as 9 y's. 6 of them cancel. I'm left with 3 of them. That's where that y to the 3rd comes from. I don't always want you guys to memorize subtraction. That's why. When it's something like this, think about just cancellation. It makes it easier. Because what happens then, a lot of people screw this up. If there were like 5 up top and 10 down below, 5 minus 10 is negative 5. So it's y to the negative 5, which is really just leaving 5 down below there. Okay, whenever there's more up top, there's some left over up top. Whenever there's more down below, there's some left over down below. Okay, so it depends on the problem. So I recommend that you just think about it like I just showed you there. Okay? Number 3. Tricky problem here, number 3. Tricky problem. For sure.
I think.
Is it?
Is it M?
Sorry.
Melissa, that was you know enough for you?
I got
Oh, show? What do I got?
A. A.
A, why A?
Because
I say C.
the X represents, well, I said it.
C maybe?
Oh,
I
God.
say C.
Is it C?
Oh wait, no, because no, there's a 2, so it's D. So there's a 2 right there, and whatever it goes by.
All right, good, Melissa. Good notice. So, here's my recommendation for you guys. Start with an XY table. List all your data points, please. Starting at the first one here. So, I'm listing data points 1, 2, 3, and 4. Now, right away, Melissa noticed this, and I want to see if we all can pick up on it. Look at your Y values. What are they going up by every time?
2.
They're going up by 2. 2. So the A value must be 2. So these are out already. Again, whatever these go up by is always your A value. So if those go up by 2, then you have a 2 there. The next question becomes, what is my solution now? How do I know whether it's D or E here? Okay, so which is your answer? I didn't hear what you said, sorry.
E.
No. E.
Isn't it?
Because you have to make it, 0.
Remember last problem when I said to you guys, think back. This is really your H value. This is really your K value every time. Your starting points are H and K. It's like your vertex. Remember the parabola of the vertex was hk? This is your vertex here. So if this is h and that's k, then what's your answer?
D.
It's D. Because look, there's no h value. So really, here's how I would write this. I would write it as y equals, and oops, y equals, I start with a 2 for a, because it goes up by 2. Then I put the square root of x minus 0 minus 1. But what's x minus 0 really?
X.
It's just x. That's why it's choice D. See how that's just x by itself? And doesn't the radical stop with x and then it's minus 1? This is my k value right there. My x value is not shown, or my h value, which is normally next to your x, this 0 here, is not shown because it's 0. X minus 0 is just x. So you don't need to show it there. The k value is negative 1. Okay, that's one way to do it. What's another way to do this problem? What's another way to do this problem? Remember your shifts? Look at your shift. This does not shift left and right. Therefore, there's no h value. So right away, let me restart this problem completely, as if I didn't even know the answer, okay? So if I look at shifts, I see that it shifts down 1. Does it go left or right at all? So there's no h value. So this is out, and this is out, because I don't want an h value, and these three don't have h values. I also know that it goes down 1, right?
Yeah.
So this one's out up here now. So now the question becomes, is it C or D? That's when you have to start looking at your increments. You have to see that this went up by 2. This gap right here is 2. This gap is 2. This gap is 2. It always goes up by 2. That's why I would choose choice D next. Okay, Melissa.
So if the H would have been like, let's say 5, that means that the line or the dot, I guess we're starting at 5.
Negative 5.
But then
Well, I'm sorry. Tell me what you're saying. Are you saying like something like this, Melissa, or something x minus?
Yeah.
Then it would be shifted left 5 units.
Okay, so the opposite.
Yes. Now, also remember, and this is last resort, I don't want you doing this, but if you really need to, you can graph all of these and see which one it matches up with.
Wow.
You can always do that, right? Graph the first one, see if it matches. Graph the second one, see. But that's a lot of work. I can do this in 20 seconds instead of like 5 minutes by graphing them all. Okay, you don't want to be graphing every single one. But if you forget for some reason, it's always a last resort. Okay, it's always a last resort. All right, number 4. Let's take a look at number 4 now. What should I do? What should I do? What should I do? Okay, distribute, absolutely. What else?
Put the negatives down.
Good, move the negatives. That's my first step, always. Distribute. So, let's distribute together. What do we get first?
9.
Good, 3 squared.
9x squared.
Bottom.
36. Then y negative 6 z 9.
Again, so what do we do first? We take care of these outside exponents. We take care of them how? By distributing. We distribute them to each term, each factor that is inside of those parentheses sets. Is that better at all? I don't know how you guys can see it back there. I can't. All right, so I distribute that. Next, what can I do? Sorry, that was a negative 5 up top there. Good, move your negatives. Not bring down, but move. Because the ones down below have to go up top. So let's start by putting y to the 6th up top and z to the 5th down below and just cross them off now. Again, that's what I'm doing to save myself some time. You clear on that?
Yeah.
Now, up top, how many y's do I really have? There are 10 of them, because there are 4 of them here and another 6 of them here. So there are 10 y's up top. How many x's are up top? 14. 2. Again, take a look at your x's here. There's only 2 x's up top. Again, 4 y's and 6 y's gave me 10 y's. Then I have 2 x's. 3 squared we said is 9. So I can put that out in front. Down below, I've got a 36 still. How many x's down below? 3 only. How many z's? 14. There's the 14 we're waiting for. Again, the x's, there are 3 of them. Those are done. There's 14 of the z's. We put the 36 over. 95. What's the last thing I have to do, guys? Because there's one more step still. I'm not done. What's in the top and the bottom? 9 and 36 and the x's. Look at your x's, guys. How many x's are up top? 2 up top. How many down below? So where are we going to be left over? Down below. Look at which one's more. There are 3 in the bottom. There are 2 up top. So I think of this as xx. I think of this as xxx. These 2 cancel with these 2. So I'm left with 1 down below here. Are we clear on that? Again, 2 up top, 3 down below, leaves 1 down below. What's 9 over 36? 4. What is it? It's not 4. 1/4. 1/4. Be careful there. So I end up with, up top, y to the 10th. No x's up top. There was a 1/4 in the beginning. I'm going to have an x and z to the 14. Again, just to make sure we're clear, we rewrote these. They're gone. I canceled these 2 with these 2. I'm left with just an x down below, which is down the bottom. 9 and 36 reduced to 1/4. Do I need that 1 up top? No, I don't. Again, I don't need the 1 up top, so you can feel free to erase it. And that would be your final answer. Okay? Good? If you're done with that, start the next one. Take a look at it. The next one we're going to simplify, but only with radicals like we did in class. So take a look at what you can do inside before you start breaking up that radical. Before you break it into 2 parts, you might have to do something in there. Yes? What's 36 divided by 9? 36. Oh, very simple. If I had 36 over 9, it would be 4 over 1. So when it's 9 over 36, it's 1/4. You're reducing them both by a factor of 9. It's like you're dividing the top and bottom by 9. Dividing this by 9, you get the 1. Dividing this by 9, because that's 9, right? Dividing this by 9, you get the 1. Dividing 36 by 9, you get 4. Plus 4. Animals are great for it too. It's ones that are and three is not the whole thing. Prince. The first prince. I don't know if that looks exactly right. Where's your man?
I'm going to get it.
It's gonna be Z, right? Z, right?
Z is a 13. Yeah, but I can't do anything because it's 4, right? So just leave it over here. Remember how you break it up into 2 parts? And you put what's left over here? Can you break that up at all? So you just leave it left over? Anything that's less than 4, you can't do anything with. Thirds and okay? You divide that by 4, so it's only 4.
Also, you mind if you're back to the
I recommend you actually write it out, people, because I've been noticing a lot of you do the right work for these problems, but make simple mistakes along the way. Okay, and I keep seeing it on your quizzes over and over again. So please be careful. Okay? We're doing it right now. So, first, I have to think to myself, what are my perfect fourths? What are my perfect fourths? So 16, that works. I'll leave it over here. Why am I leaving 16 on the left-hand side? Because what is it? Yeah, the fourth root of 16 turns out to be 2. So I can leave that alone. Now, how many of these x's out of all 5 of them can I move over here?
1. Wait, you mean that way?
Over here.
Oh, 4.
And how many over here?
1.
Because what's 4? This 4 and this 1 get me back to 5, don't they?
Yeah.
But remember, I want things that can be divided by whatever my index is over here. This 4 can be divided by 4. That's why I chose that number. Now, 6. What can I break 6 into?
4 and
4 and 2. Z.
2. Well, I don't know.
It stays on the right side here. Z to the third, you can break it up into Z to the 1 and Z to the 2, but neither of those help over here anyway. So just leave Z to the third over here. So whenever your exponent is less than your index, you automatically move it over here. The exponent, 3, is less than the index, 4, thus it stays under the radical. What about the 24?
It stays.
Where, left or right?
Letter.
Why?
It's even.
It's even with the
It's a multiple of 4 we need, right?
Yeah.
Let's use our words correctly. So here, that's w to the 24. How do I know what numbers I'm looking for? All I have to remember is just list the multiples of 4. So if you can get any of the exponents to look like those numbers that you see along the top of the page, they're going to go on the left-hand side. And clearly, 4, 4, and 24, there's 4, there's 24. The numbers in between we didn't use, no big deal. Now, I have to reduce still. This gets left alone. I'm not going to do anything with it. What about the left-hand side? Tell me, somebody, raise your hand. What does this turn out to be on the left-hand side? What's right?
4, 2.
2. Remember, 2 times 2 times 2 times 2. I need 4 numbers that multiply to give me 16. Continue.
X, Y, W,
Good. And over here?
right.
Just carry it over. Again, you take your exponent and divide it by your index. 4 over 4 is 1. 4 over 4 is 1. 24 over 4 is 6. I have to also remember that the fourth root of 16 is 2, not 4. A lot of people think 4 because it's the square root of 16. Again, you need to find a number when multiplied by itself 4 times that gives you 16. Okay? We're going to do another one of these in a second I'm going to put up here. Let's go to the last one, then I'll put up another one in a minute. And on the right-hand side, remember, guys, you can't just forget about it. You got to carry it down. A lot of people, here's what I'm seeing. I'm seeing this answer right here with a radical around it still. There's no radical anymore. Once you get rid of it, it's gone. You don't have a radical anymore on the left side. A lot of you are keeping the radical there. It's gone once you take its value. Here, once you evaluate it, you leave it alone. All right, let's do the last one together, and then we'll do another example of that previous one we just did. So, I gave you an XY table there. Why? Yeah, just to fill it in, to remind you that it might help you to pick values for X, right? So, on the left-hand side, list your perfect squares over here, please. Start by listing your perfect squares on the left of it. You're not going to use them, but you're going to use them to figure out what X is. Now, what number, when I say what number, I'm talking about X. What number, when when 1 is added to it, becomes 0?
-1.
-1. So that's my first value there. What number, when added to 1, gives you 1?
2. No.
Zero.
Try it, guys. 0. 0 plus 1 gives you that 1 that's there. After that, it gets easier. What number plus 1 gives me 4?
3.
What number plus 1 gives me 9?
8.
What am I doing, really?
Just
I'm just taking away 1 every time. Notice that? 15, 24. It's just they're all 1 less. They're all 1 less because this was a plus 1. Remember the whole H, you do the opposite? That's where that comes in again. All right. The Y values. What's the first Y value going to be automatically?
2.
Y, Leslie? Perfect job. Well done, miss. This K value always goes in the first Y spot. Then I can just add whatever A is every time.
3,
What is the A that's in front here?
1,
There's really a 1 there. So, go ahead, Karen.
3, 4, 5, 6, 7.
Good. Again, these are much easier to do than plugging in the number for X every time if you remember how to do this technique. And now at this point I have to say to myself, my X or my domain. I'm not going to have to write it, but I should know it to graph, right? I didn't ask you to state the domain. But if you wanted to state the domain, what's the smallest X value?
24.
Look at your X value, the smallest. So everything X is bigger than or equal to -1. What's the range going to be?
Infinity.
What's the range going to be?
-1 to infinite, right?
That's the domain. Domain is this right here. That is, this right here, Andy, is -1. Whoops. With a bracket.
So X is less is more than 20. So less. More than
Y, not X.
I mean Y.
Oh, Y2. Yeah.
More than 7.
Oh, 2.
Or, in bracket form, that would be my domain and range for this problem. Again, I'm not asking you to list it, but it will help you when you're graphing. Because now I know that I don't really care about negative X values that much. There's only one of them. And my Y values are all positive. So this helps me create my X and Y axis. Again, this will help me create my X and Y axis. So, I'm going to erase what I have over here, sorry. Just because I want to use the graph. Now, if I know that X only goes as small as -1, all I have to go back to is -1 for the X. So I'm going to leave like, how far am I going to go up to? 24, right? So what might I go by? 2, 4, go by 5s, I can go by 3s, anything. But I'm not going to go by 1s, right? It's not worth it. So let's leave behind maybe 2 boxes on the left side. But do I need any negative Y values?
No.
Look at the Y values. What's the smallest Y value? It's 2, isn't it? The smallest value here? So I don't need a negative Y, so I really don't even have to go down anymore. I can go all the way down to the bottom there for X. So this helps me choose my X and Y axis. Next, look at the Y values. They go from 2 all the way up to 7. So I might go by 1s, which is fine, but I'm probably going to go like every other box. Look how many boxes you have, guys, from top to bottom. There's a lot of them. So every box, make that increment of 1, 2, 3, 4, 5, 6, and there's 7 up top. Look how nice that looks. Isn't that nice?
It's beautiful.
You should do that every time.
I know.
Along the x-axis, what am I going to go by now?
1.
I really, if I go by 2s every box, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. That'll work, right?
Yeah.
So let's do that. But now, just to make it easier for myself, okay, I'm going to start by labeling the 2, and I'm going to label them all, but I'm not going to label every one. I'm just going to do this. Oops, 12, 14, 16, 18, whoops, there's 20. Okay, I'm not going to label every one of them because it's a waste of my time and it's just going to get too clogged. So I'm going to put this -2 back here. Remember, if you go by 2s on the x, you got to go by 2s on the negative x also. If you go by 1s on the y like this, you got to be consistent along the y-axis. Consistency among each axis. Okay, each axis needs to be consistent. And now just plot your points. -1 is right here. And then I go up to 2. So my first point, I'll use red. There's my first point right there. Again, I go over 1 to the left 1, and I go up to 2. And doesn't that make sense? Look at your original function. This tells me go left 1. This tells me go up 2. That's a positive 2, so you can see clearly. Go up by 2. And what did we do? We went left 1, and we went up 2. Just like my shifting tells me to do. After that, I go to 0, 3. Then I go to 3, 4. Here's 2. Here's 4. Remember, these go by 2s on the x-axis. So here's the 3 mark right there. And I want to go up to 4. So I'm going to follow that all the way up to 4. That's right there. Then I'm going to go to 8, 5. Here's 8, and I go up to 5. Then I go to 15, 6. 15 is right, where's 10? 10 is here. 12, 14, here's 15 right there. So I go to 15 and I go up to 6. And then finally, 24, 7. Here's 24 at the end, and I want to go all the way up to 7. And take a look at your shape. Again, it's the same general curve. Okay? Now, question for you. Before we do one more example, I want to do one more of the last one. If this had been, instead of just a 1 out in front, what if the function had looked the same, but there had been a negative symbol out in front here? What would the y values have done? So instead of 2, 3, 4, 5, 6, 7, Karen, it would be what?
2, 1, 0, -1, -2.
So if there had been a negative out front, that's really a -1, these would have gone down by 1. So my graph would have actually been down here, wouldn't it? So I want you to remember, guys, when when A is positive, your graph's going to look like that. If A is negative, it's going to look like that. Okay, again, when A is positive, it's going to look like what we just had there. But if A is ever negative, it's going to go down. It's going to dip down. So if you have a multiple choice and you see the graph looks like that, right away, you know A's got to be negative. So you can rule out any of the positive ones. Okay, again, because had there been a negative here, these numbers would have all changed. It would have been 1, 0, -1, -2, -3, which means I would have had to carry down this way. Okay, I would carry on that way. All right, let's do one more problem like this one here. Okay, just to reiterate this. So, let's say we now have the third root of -8 x to the 4th z to the -6th parentheses y w to the 4th all to the 5th. Now, before you start breaking this up and doing all that work, do what you need to do inside. Distribute that 5, do something with that -6. Okay, you might have to move that somewhere like we've done. Yep. What do we got, Andy?
Alright, -8 x to the 4th z to the -6.
Okay, but if it's a negative, where is it going to move to?
Oh, down.
So I'm going to extend my radical line now, right? So see what Andy already said here, guys? See that z to the 6th? It's in the bottom now because it was in the top before. Continue.
Y to the 5th and w to the 20th.
Well done. All right, that's my first step. Now, you see the bottom here? Don't let that intimidate you at all. It's the same thing. You still want to break it up if you need to. So in this part now, we're going to now take this fraction, and we're going to break up the top and break up the bottom. So I'm going to have a cube root of something over here times a cube root again of something over here. Now, I've got x to the 4th. What am I going to do with the x to the 4th?
Take it down to x to the 3rd.
Good. So I leave the 8 alone over here. This is going to become x to the 3rd. This is going to become an x over here. I'm making believe that we're going to have fractions of both. We're not, obviously. Or we might, but in this case, we're not. Should have made it harder. Let's do this, guys, just to make it a little more difficult. Make this z, make this just -7 instead. Okay, so make this a z to the 7th. Change your original problem to -7 and 7, so that we can see this more clearly. Okay? All right. Now, we've broken up the x's. What about the y values? Barbosa, tell me for the y values. What's going to go over here? How many of them? And how many are left then? Well done. Next. The 20. Anybody want to try the 20? Take a stab at that one.
Is it going to 8?
15.
18. Be careful. 15 is a multiple of 20. Is a multiple of 3. List your multiples of 3. Which one is bigger though, 15 or 18? 18 is bigger. So we want to take 18 of them, put them over here, and take the remaining 2 and put them over here. Remember, guys, whatever's left over here, those exponents have to be less than your index, right? Again, Look at all of your exponents. There's a 1, a 2, and a 2. They're always less than the index because they can't get broken down. So if you did 15 over here, Karen, if you did 15 over here, you would have had 5 left here, right? But 5 is bigger than that 3, so that means that that can be further broken up. What about the z to the 7? How many on each side?
6 and 1.
6 and 1. Can I do anything with the right-hand side?
No.
There's nothing I can do because all of my exponents are less than the 3 index. But the left-hand side, I for sure can do something here. Cube root of negative 8.
-2.
What is it? Negative 2, right? Negative 2, I think I heard. I hope I heard. Because 2 times 2 times 2 is 8. Therefore, it's just negative 2 there. Next.
X, Y.
X and Y and
Why are x, y? Why are their exponents not there?
It's just a 1.
It's just a 1. Remember, 3 divided by 3 is 1. 3 divided by 3 is 1. What about the w?
6.
What about the z?
Squared.
Very good.
Would you have to put multiply?
You don't have to, no. And you're not usually going to see that. If you want to put a little dot there, you can, but you're not going to see that on the actual SAT. If they have a problem like this, they'll leave it without that dot. Okay, that won't be there. That'll be your final answer.
Wait, how come you don't say that? Maybe it's negative 2 down.
Down where?
No.
Only if the exponent is negative, I move.
Oh,
Remember?
okay.
Remember the z was the negative 7? It was
Yeah.
the exponent. There's no exponent here. It's just a 2. Remember, guys, tomorrow, 5 questions on your test. That's it. You're going to come in. We're going to start by taking our real quiz on concept 51, which is the square root function graphic stuff that we just did a minute ago. That's your real quiz for that. I'll give you about 5 to 10 minutes. Then I'm going to give you about 30, 35 minutes for your test. That's all you need. It's only 5 problems. But since there's only 5 problems, every problem is worth 20% of the grade. So if you get one multiple choice wrong, you're already down to an 80 for the test. Okay, keep that in mind. There's going to be, I'll tell you right now, there's going to be 3 multiple choice and 2 free response. 3 multiple choice, 2 free response. Make sure you get all 3 of these right, and make sure you get most of these 2 right to get a good grade here. There's no partial credit for your multiple choice. Okay, so you have to make sure you get those 3 right there. And I'll tell you now, you're going to have questions similar to the ones you see in your packet. Okay, similar to the ones you see in your packet. Tonight, what you should be doing, several things. Notes, that's the first thing. Homeworks, second thing. Old quizzes, the third thing. And the fourth thing is just, again, review your packet here. Okay, you have 4 things to study from. Your notes, your old quizzes, your old homeworks, and your review packet. I want you to be looking at all of that stuff. And if you really need more practice, I also do put problems at the bottom of your homework out of your textbook. So you could always look in there also. Okay, if you really want more practice and you want me to, if you email me tonight before like 9 o'clock, I'll send you some more problems in a month. Maybe not after like 9 or 10.
We still send our homework for
You can turn, guys, you can turn in your homeworks if you want to make anything up, or even if you just want the grade for the homework, I'll give you the grade for it, like I said.
By tomorrow, though? By tomorrow, like all the other ones?
Yeah, but if you want to do it by tomorrow, I need it before 6th period.
Yeah.
So either during break or during your lunch. If I'm not in your lunch, you need to put it on my desk or bring it somewhere, you know?
Yeah.
Bring it to the workroom or bring it to the main office and put it in my...
Do you show the homework for Edna?
Are all the homeworks on Edna? Yes, they all are. Under assignments. If you go under assignments, just have to see your homework. Ed.